equation graphically, what's the first thing that we're going to do? I would get 0 on one side. It's not a requirement, but it makes it a little easier because then you're looking at the x-axis instead of all over the place. So I would get the, subtract the 6 over, and in y equals, I would type x squared, is everyone doing this with me? Plus x minus 6. So I'm going to show you that picture of my calculator. Okay, x squared plus x minus 6. The window on my calculator is kind of messed up. In y2, I'm going to put 0. This step is optional. You could use the zeros button, but if you like using the intersection button, what does it mean to find an intersection? To find where they cross, and what kind of word is they? Plural, right there. Two things that we're finding that cross. So I'm going to put 0 in y2. If you like using the intersection button, you do have to put 0 in y2. Push graph, my window's really messed up. I'm going to go back to Zoom 6, see if I see it. If not, I'll adjust accordingly. Do I see where that crosses the x-axis, or y equals 0? So I want to find those. So I'm going to go to second trace. Y'all remember doing this yesterday now? Yeah, y'all need to work on that. Second trace number 5, which is intersect. You can just push enter 3 times. When you do, it will give you a random one of the 2 intersections, which is fine. I want both, so it doesn't really matter where we start. So I get x equals 2, y equals 0. X equals 2 is the solution, right? That's the what I'm trying to find. What does x equal? So x equals 2, write that down. This next piece, pay attention. I'm going to go to second trace, and I'm going to go back to intersection again, but this time I'm going to move over to the other intersection. Your calculator will find the intersection that is closest to your tick mark. So then I'm going to push enter 3 times, and I get -3. X equals -3. So I get 2 intersections, x equals 2 and x equals -3. Second trace 5. Well, but then you do it again to find the second one. Yes, you have to do it. You have to do the intersection button twice. So I get x equals 2 and x equals -3. Just to show you what we just did there, I could have solved that by hand, couldn't I? Yeah. X squared plus x minus 6 equals 0. It does factor. You see how the calculator is giving us exactly what we would do, right? So it's just another option, calculator option. So let's look at the next one. X squared minus 4x plus 1. Put that in y equals. In y2, I'm going to put 0. And graph that. Is everyone with me? I'm going to go to second trace 5 and push enter 3 times. This time I get 0.268 if I round to 3 decimal places, right? What does that mean? Why? It's a decimal. If I solve this by hand, what do you think I would get? Something with a square root involved still, probably, right? Something like 2 plus or minus the square root of 3, right? Those types of answers. So, is there a time and place for an exact answer? Yeah. Is there a time and place for a decimal value? Yes. So, if you want a decimal value, is that a lot faster than the quadratic formula? So I would say if you're going to want a decimal value, don't ever do the quadratic formula. Skip to graphing. If you want an exact answer, we're going to have to use the quadratic formula. It depends on what you're doing. If you're doing an ACT problem where all the answers are written in square root format, then you'll probably want to do an exact answer. If you're working a problem in physics on when does the ball hit the ground, I probably want to know time in decimal seconds. So it just kind of depends on what we're doing there. Okay, second, trace 5, move over to the right, and push enter 3 times. Did someone write that first one down? Good, because I don't remember it. So the first one was 0.226, and the other ones? I don't know the third decimal place. Pay attention to what the book says around to if you are doing decimal places. Any questions about that? What I don't want is don't ever round this to a whole number, right? It wasn't a whole number. Make sure you know and I know that you knew it wasn't a whole number. Give me some decimal places after that. My preference would be if it doesn't tell you otherwise, fine. Find the x and y intercepts of these quadratic equations. Can I do that in the calculator? I can do it by hand also. To find x-intercepts, just quick reminder, how do we find x and y-intercepts in general? On your last mastery exam, what do you do to find x and y-intercepts? Put 0 in for x to find a y-intercept, put 0 in for y to find the x-intercept. I would argue that y-intercepts are easier by hand, but I'll show you how to do them in the calculator. I already know the y-intercept for the first one's -7 and the second one's 3. Does everyone agree? I can see that pretty easy, so I don't know if it's worth your while to dig out a calculator to find that, but if you must. And then the x-intercepts are a little tougher. To find x-intercepts by hand, we're looking at when the function equals 0. So that would be factoring, quadratic formula, or calculator. I'm going to go ahead and solve these in the calculator just because we did quadratic formula and factoring yesterday, so just more calculator practice. But x-intercepts are where we cross the x-axis. So if I go to my calculator and type in 2x squared minus 13x minus 7 in y1. In y2, I'm going to go ahead and leave 0 in y2. Why would I do that? So that way I can find the intersection when x equals 0, that x-intercept. There is another button you can use. I'll show you that while we're doing this problem. Graph it. I can see both intersections. I know this is a parabola, it's a quadratic, so I expect to see 2 intersections there. To find the y-intercept, if you want to use the calculator, everyone watching this, you can go to second, trace, and push the value button, and type in x equals 0. Isn't that what we want to do, put 0 in for x? And so it'll give you the -7. Again, probably was faster just by looking at the equation, but if you ever want to do that in the calculator, that's how you do that. To find the x-intercepts, my favorite way is to go to second trace 5, push enter 3 times. I get -1/2 for the first one. For the second one, I'm going to do the second one different just to show you this other button. If you don't like having to remember to put 0 in y2, you can use the zeros button. Aren't zeros x-intercepts? Isn't that the same thing? So you can use the zeros button. To use the zeros button, you have to go over to the x-intercept you were looking for. Oops, too low. Get your cursor close to that x-intercept. Go to the left of it and push enter. Go to the right of that intersection and push enter. And then get close to it and push enter again. The left and right thing is hard for people sometimes, and that's why I use the intersection button more often. But so is the other x-intercept. So 7 and -1/2, is that what we got? Could you see how this could factor? to have a 7 1/2 involved in the answer. 2 and 1, 1 and 7, probably going to be your. So we could also factor that. I'm not writing those answers down, so someone, y'all write those down. So when I get up, I'll go put them down so that they're on the notes. You'll have to remind me what they were. Try the next one. Okay. What does Secretary find? 5 find? What are you trying to find?
Would that be the... I'm trying to find the intersection.
Okay. Intersection. What? Oh. You have see, your other one wasn't graphing, so it wasn't finding an intersection.
Thank you.
You're welcome. Okay, go back to y equals. Do the other one. It's blank. What do you mean it's blank? Okay, it is a graph that never crosses the x-axis. If you were to do the quadratic formula, you would get imaginary answers, correct? What's the answer for x-intercepts, though? When does it cross the x-axis? It doesn't, so no x-intercepts. Imaginary answers are never the answer to x-intercepts. Imaginary numbers aren't real, so they aren't on a coordinate plane. Does that make sense? So when you are looking for x-intercepts, if the answer is imaginary, then it's none. There are no x-intercepts. We still have to find a y-intercept, and how would we do that? Plug 0 in for x. Which we knew a long time ago that was going to be 3. It was easier in our head than in the calculator, but we'll have both options. No x-intercept for the x-intercepts, and the y-intercept is 0, 3. So I'll write that down. Sorry. Normally I don't go back and forth to my desk this helps. So 0, 3 is the y-intercept, no x-intercepts, and someone remind me what this was, negative 1/2?
Yeah, and like
0.
7 or something.
And then 7, 0?
Yeah.
And 0, negative 7?
Yeah, works for me. You're about to write that part down.
These two were the x-intercepts, and this one was the y-intercept. I would take it either way. You wrote x equals the x-intercept. This way I don't have to label them. You know what I mean by that? Because I know if it's 0, then a number has to have a y-intercept. I know if it's a number that's 0. Okay. Identify the easiest way to solve it and solve it. Algebraically, so no more calculator for now. Even if I ask you to solve algebraically, could you check it in your calculator? Okay, let's look at the first one. What is the easiest way to solve the first one? formula is the only option. On the next one, I would say there's two correct answers. If you're really good at factoring, does this one factor?
Yeah.
If you're good at factoring, I'd say factoring's the easiest. If you stink at factoring, then quadratic formula might be the easiest. You get to make that decision at this point. Which one is easier for you? I'm going to show you both options, and then you can, on your homework, if you cover one like this, you get to choose. If I'm factoring 3 and 1, 1 and 3, and 1 and 2, adding to get 5, 3 plus 2, that's to give you 5. And so I get x and 3x, 1 and 2, both subtraction. So x is 1, and this one might take me a little work. Add the 2 over, divide by 3. 1 and 2/3. So that is how you would solve that by factoring. How many of you would have picked that? I would too. How many of you would not have picked that? Just would do the quadratic formula. Okay, so let's do that option. X equals negative b minus the square root of b squared minus 4 times a times b all over 2a. Negative 5 squared is 25. Minus 24 is 1. Does everyone agree? Underneath that graph, I'll get 1. What's the square root of 1? 1. So 5 plus 1 over 6 is 6 over 6, which gives me 1. 5 minus 1 is negative 4. 5 minus 1 is 5. 4 over 6 reduces to 2/3. Maybe next year. This is a plus sign, so they have to be the same sign. And I have to add it in negative 5. So they would have to both. So 5, so we can separate this into 2 pieces. 5 plus 1 divided by 6. 6 over 6. And then 5 times 1. Yeah, it's negative b. So a negative negative makes a positive. But I just guess we need to get those negative things. Yeah, check those. I taught y'all the song yesterday. I actually didn't learn the song until I was teaching. I think college out of UCLA students taught me the song. My teacher had us memorize the quadratic formula as opposite of b. What's your axis where I see all of 2a, which I kind of like a little better, but it's not going to fit the song. But he did opposite of b. That way you could just change the sign. So kind of a good way to practice. Any questions on that? Okay, last one. It's a word problem, but don't let it scare you. I made it. Okay, so you throw your hot algebra book up in the air off of a 50-foot cliff. The height of the notebook can be given by that function. Had a bad day. Sorry. You can tell I wrote this problem from a book to a notebook. How long will it take for the notebook to well, what is the maximum height the notebook reaches? We are going to use our calculator to do this. We wouldn't have to use our calculator for part A, but we would have to use our calculator for part B. A few minutes to write. I have one of those tablets that I can write on. I need to get it hooked up so that when I'm doing this, I don't have to do it.
You should.
Yeah, I've used it before. Well, I use so many jump drives. It uses a flash drive to work. Slots full.
Just one that has multiple.
I need to. I used to have one, and I think
You can have like 12
yeah, I need another one.
if I remember how to teach one.
Teachers and students, please excuse the interruption. Kristen Oliver to the high school office. Kristen Oliver.
Okay, NY1. Or was anyone still writing? Okay, sorry. I will leave that up. Equation number. Yeah, I worked hard on that. It's a modification of a calculus problem. I have a calculus one that's the same calculus, but no, just the physics part of it. They have to do both of those by hand.
Turning, you just do it.
Okay. Is everyone ready for me to pull my calculator screen up? I am gonna do that, but first we'll do the hit the ground part. Okay. Well. My computer's gonna stall. That's okay. Okay. So I have the equation typed in y1. What do you know about my y values on this function? Okay, at least 50, right? I'm taking the book from a 50-foot cliff and throwing it up, right? For some reason, I didn't just drop it. I was really mad. Threw it up. I don't know. So the height has to be somewhere above 50, right? So in my y max, I'm going to put 100. We'll go with that. We'll guess. And that was plenty big, probably a little bit too big. What does the x represent? Which you might even look at the equation. It gives you a good hint because it's not even an x. It's time, right?
Yeah.
That's why they called it t. So it doesn't say, but it is in seconds. This isn't feet per second. So if that's in seconds, why is it so skinny? Well, is it going to take a book a real long time to fall? No. So it's obviously less than 10 seconds. So that's why it's so squeezed in. If you had done negative 100 to 100 on all of your screens, would you see a good picture of this? No. So remember, it's not wise to just randomly zoom in and out. It's good to think about what the values mean. And so y was the height of the book. We know it's going to be kind of big because we're throwing it off of a 50-foot cliff. But the x value is time. It's not going to take a real long time for the book to hit the ground. So think about those things when you're working a word problem. Would you agree this is when the book hits the ground? Right here? Because we're at 50 feet. When I get down to 0 feet, that's when I hit the ground. So I'm going to find that. Now, I do have technically two places where I cross the x-axis. Is the one on the left useful to me? Not unless you can go back in time, right? That's a negative time value, so that has no importance on our problem. So only the one on the right makes sense. So I'm going to go to second trace 5. I'm going to move over to the right-hand curve. By the way, I do still have 0 in y2. I am leaving it there for these problems. And 2.5 seconds. So how long does it take? It takes 2.5 seconds for the book to hit the ground. Any questions about that so far? No, remember me saying don't do this. Because what's that?
Time. Oh, okay.
So that's so big, you're not seeing anything. So don't just better.
Miss King,
Yes, ma'am.
I need Hunter Moon, Molson, Addie Nelson,
Uh-huh.
and Gage Windsor.
Okay, they'll be right down.
Thanks.
You're welcome.
So just don't mess with.
Well, always think about what's X mean and what's Y mean. In this case, X was time,
So you don't need to go.
so you wouldn't want, it's not going to take the book very long to fall. 2.5 for the first answer. Okay, the next one, I'm going to look at the maximum height of the book. Wouldn't you agree that it's at this peak? This is completely new to you, so this is a new button in this class. I'm sure you've used it in another class. And there's a button on your calculator. Go to second trace. Which button do you think we're going to use?
Maximum.
Maximum button. We will spend some time learning how to do this by hand in the next couple of sections, but for today, I just wanted you to introduce you to the button. So I'm going to click maybe I can make this bigger now. I'm going to click number 4, which is the maximum button. Everyone watch this very carefully and stay with me very closely. The first thing I'm going to do, the minute you do this first, move your cursor up to the maximum. Don't do anything else yet, just move your cursor up to the maximum where you're flashing in the area of the maximum. Because then the left and right make more sense. Left of the maximum. So once you're on the maximum, now go to the left. Would you agree I'm to the left of the maximum? Push enter. Then it says right bound, so I'm going to go to the right of the maximum. What you're doing in your calculator is isolating where y values and just testing to see which one's the best you gave it. So if you give it the wrong 2 in between values, it's just going to give you the maximum on whatever interval. Anyway, write down, push enter. Guess, get it close to the maximum and push enter. And it's 56.25.
For that 6 feet in